I'm CK. Today we've got a module from Shakmat Modular. It's their Mod Medusa. It's a 4-output Euclidian LFO. Now, Euclidean triggers that you might use for a sequencer, for example, or creating modified or random sequences, come along and you get an input clock and it'll split it up depending on various settings and shift things and do whatever for different rhythmic patterns. The difference here is, besides being doing all those things, it does it to waveforms versus to simple pulses. And again, it's got 4 correlated outputs, so it looks like a pretty interesting unit and probably very useful for pseudo-random sequences or pseudo-random CV that you want to send out. So we'll put it together and then see how it works. And I hope you enjoy the video. The bag from Shakmat in Brussels, Belgium, and I, as you can probably tell, picked this up from thonk.co.uk, which is where I get most of my eurorack kits. This has got a date on it of July 13th, 2023, so it's a relatively recent package. I don't know if the product itself is relatively recent. Let me open. This is kit number K02, so I don't think many people have built this kit. This may have a pull tab. Look at that, it has a pull tab. I don't have to attack it like an animal. Let's see what we got. Got some paper bags, which are always good. I suspect that there may be a lot of surface mount already installed, but we'll see. Here's a knob. It's not a great knob, it's plastic. No set screws. Let me get my mechanical bin over there. And here is the piece of paper. We'll get that out. This is somewhat standard packaging from Shakmat, built and designed in the EU. Whoop. I have these stickers, but I do not have this sticker. That's a nice new sticker. So it's not a build guide. This is the user manual. Goes through everything interesting. We'll get to that later, of course. Eurorack power supply. Here's the front panel and circuit board. So 4 knobs. Let's see what this looks like. Download the building guide at shakmat.com. Okay, I will do that. Let's look at the front panel first. And we've got length, which I assume may be the length of peak-to-peak waveform. Density, that's how many pulses per time unit. So if your clock, if you have it set real low, it gives no pulses. If you have it set there, maybe it'll do 3 pulses per clock or something like that. I'm just speculating right now, but that's what density generally does in this Euclidean stuff. Looks like 4 LEDs, shift and VCA, I don't know what that is. Menu button, that looks like a long press to bring up the menu. Length plus, sync, uni, tap tempo. I don't know if that's going to be a button or a jack. We'll see. Then dividing table, modes, shape for the waveform, and symmetry. So as you can see on this triangle wave in the center, it's a full triangle wave. Take symmetry all the way this way, sharp leading edge, take all the way this way, sharp trailing edge. Clock, VCA, length, dist, shape, sim, reset, AGT, don't know what that is, and then 4 outs, which are always active. So that'll be good. And again, K02. And here is the board. ROSE compliant. Couple of, this looks like a programming interface. Oh, and this PCB version 1.0, February 22. Power connector goes there, and then here's a jumper. Don't know what that would be for, but we'll find out. And yeah, a lot of surface mount, all of it already installed. And then something here, I don't know what that is, but that's okay. Timing crystal. And yeah, I guess these look like tap switches. And then a bunch of jacks here, pot, click switch, click switch, click switch, click switch. And these are the 4 LEDs I mentioned with their current limiting surface mount resistors right below them. So it doesn't look like it's going to be too challenging a job. As I say that, let me go back and look. Okay, we're not doing any soldering on this side of the board except for the power connector. And where did that go? Where did it go? It's over here. And we're not touching any, or not even close to any surface mount components near those solder points, so we don't have to be particularly careful. I mean, beyond regular care. So we've got all little bags, and I'm sure, this says pack 2 of 3, and this is pack 2 of 3, and this is pack 3 of 3. So they may have mispacked my kit. Those are the pots. And those are the pots. So we don't have pack 1. So let me go look at the build guide and I'll figure out what's going on here. And yeah, we're missing pack 1. They gave me 2 pack 2s instead of a pack 1. And pack 1 contains 3 electrolytics, 3 tack switches, 3 tack switch caps, 4 green LEDs, and 4 amber LED push buttons, or 2 amber LED push buttons. And I have everything except the LED push buttons in spare. I've got enough tack switches and caps, but I don't have the LED push buttons. So we'll put this aside and come back to it when I get the replacement parts. Sent an email to Thonk, and they got me bag 1. Again, it's not a huge deal. If we look at bag 1, it's not a huge deal except for, no. Except for these switches. I don't have any spares of these. These have LEDs in them, and they're clicky. They're like tactile switches, but they've got LEDs in them. And you may notice here, they do go in a particular way, and they've marked the switches with a little red indicator to let you know how they go together. So now we have 1, which is in the bin, 2, and a spare set of 2s just in case, and 2 is mainly just the pots. Oh, and a couple of more switches and a power header and an LED. So there's a couple of more things in there that I just dropped in here to confuse myself. And then in bag 3, we've got all the jacks and a couple more switches. Gosh, there's a lot of little switches. How many switches are there like that? I don't see that many. Where's the front panel? I just had the front panel, for crying out loud. I don't know where I put it. Because I've got switch. Oh, there are about 4 of them. Okay. So let's see. This is not the build guide. Let's pull up the build guide. I'll get the soldering iron heated up and pull up the build guide, and we'll get this thing underway. Okay, I'm going to dump everything out into bags 1, 2, and 3 go in separate bins. The first thing we're going to do is put on, in the build guide, is put on the power header, which of course is in bag 2. So, don't make assumptions, huh? Goes on the back side of the board, of course. So we'll set that down, and it is not keyed. It is an open header. So you will have to pay attention yourself to make sure the red stripe goes on the negative 12 volt side. And now we're going to put the 22 microfarad caps on. And it's interesting that you really have to go by the build guide and the build guide pictures, because besides the fact that there are no values listed on the PCB, there are also no placement numbers. You know, normally it'll say C1, C2, C3, R1, R2, R3, and so on. But this board does not do that, so you have to look at the pictures. The plus sign showing where the long lead goes is very, very tiny. I'm sorry, they want us to put the jacks on now? I guess. I mean, we normally do jacks and pots and switches last, because then we put the front panel on to make sure they're all aligned. But Shakmat would like us to do it a little differently this time and put the jacks on now. That's very interesting. Okay, so again, because we're basically only doing, except for the electrolytics, we're only doing front panel components. So I'm going to take these back off for the moment, and I'm going to do it in the way that I'm more comfortable with. The first thing I'm going to do is I'm going to put the, and I'll tell you why when I'm doing it also. First I'm going to solder these caps. So the reason why, and I'm going to put all the mechanical components on and then solder them with the front panel on like I typically do. I'm not going to piecemeal them. I just am more personally comfortable like that. Because then I'm sure everything is going to be correct, and because I'm going to do that, I'm going to put these things that have somewhat splayed out legs that take a little force to go through. I'm going to put those in before I put the jacks on, because if you don't, every time you push one of and the jacks aren't soldered, every time you push one of these on, the jacks hop out of their position, which is no fun. I'm going to do all of the front panel components except the LEDs. Okay, are all 4 pots the same value? B110, that's linear 10K, linear 10K, linear 10K, and linear 10K. And they do mention that if they have index pins, you should remove them, and either they didn't come with them or they removed them already for us, so we don't have to worry about taking that off. So now we'll put the 10K pots on. Now we're going to put all these LED switches on, and I wonder why they're in 3 separate bags. I guess there's a P listing here. Maybe P3 means it was in the third bag or pack. Okay, that's what it's saying. That's why they've done these this way. I'm sorry, I got confused. So the ambers, which were in bag 1, go... I'm looking at this orientation. There are little round pegs and a square peg that fit into the cutouts on the PCB. Is my light not right? What is going on with my light? So you got to make sure those are aligned, or else this won't work. We got another amber. You can actually look at the back of the board and make sure you've got them the right way. Oops, I think I just did that wrong. Yes, I did. The third pin on all these is being a pain. Okay, and then the pack 3 one, which is red-green, and we'll go up here. Now again, for each step, the Shakmat instructions say go ahead and slap the front panel on and solder them, and then take the front panel back off. And I don't want to do that, so I'm not going to do that. What I am going to do is now put the jacks on, and then do all those, and we will come back for the LEDs, because there's a bunch of LEDs. So we'll get all these mechanical components settled, and then we'll come back and do the LEDs, and I will speed through this. I will speed up playback, because now I'm just setting jacks in place and then doing a bunch of soldering. Actually, I will speed up jack placement, and then we'll put the front panel on in real time. Okay, now without the LEDs on, let's go ahead and put the front panel on and get all these mechanical components lined up and then soldered in place. I will admit, getting those little buttons through the front panel hole was a bit of a pain, as you may have noticed. So now let me get a little clamp. Clamp it in the middle. And we will do a little bit of soldering here. I'm going to solder one leg of this pot. Then I'm going to go down here, make sure this is all flat, and it is. I'm going to solder this jack and this jack. Back over, put one panel nut on this jack that I soldered. Oops. Not too tight, just a little bit more than finger tight. Now I know everything is level and set right. Push all those to make sure they're all good. Push all those to make sure they're all down. All the LEDs I have omitted for right now. So now I'll go ahead and solder all these connections, and again we'll do that, play that back in fast motion. So that's all those parts, and we'll take the panel nuts back off now, because now we're going to be messing about with the LEDs. By the way, if you're wondering what this is a handy little device for doing jack PCB nuts that I picked up from Thonk. I forget the company that makes it, and I apologize to those folks because it's a really good tool and they should get credit for it. But I forget. You notice I didn't put the cap extensions on these other switches yet either. We'll get to that. And now we will put all our LEDs on. And let's see, where does he go through step by step on that? And we'll use our LED buddy for fun. So we should have 4 greens, and we can check that here. That's green, 2.4 volts, 6 milliamps, 470 ohm resistor for current limiting if you want. Let's check all 4 of them just to be sure. I built this little guy a while ago. It's videos on the channel. I'll try to remember to link it in the description, but I probably won't, because that's the kind of guy I am. So that's all the greens. Now we want the amber greens, which are, I believe, are these. I forget how, I think this will fire both colors off sequentially. There's white. Well, I'm in the wrong bin. Oh yeah, because he doesn't have it in order. It says pack 1 green LEDs, amber green LEDs, pack 3, white LEDs, pack 2. He didn't go in order. I don't know why. So there's amber. Probably, that's 1.9 volts, so my device is not choosing to go up to the green side. But it doesn't matter. We can see that it's amber and there are no other ambers in the kit. So these go in this cluster over here. And they did put kind of orange and green highlighter or on the leads, legs of these, leads, legs, whatever you want to say, of these LEDs, so you know what they are, even if you mix them up with the other LEDs or mix the bags up, you'll still be able to figure it out. And we've got the 4 white LEDs, and where do they go? They go over here. And I'm double checking that all my longs are on the same side. Now I'm pushing all the LEDs through their holes. Now these do stick out a little bit, and the author of the build guide says if you want them flush, you can put a little piece of tape along them to flush them up. But I will say this, and this is me, you can do whatever you want, whatever works for you, but because I'm often not looking dead on a panel or on a module, I may be looking to the side or a little off or a little up or down, since I've got a wall of modules, as you can imagine. I actually like the LEDs to protrude a little bit, because I can see them a little bit better from a non-straight-on viewpoint. And that is why I like to go ahead and put them through that way. Now we'll go ahead and solder all of them. Now I'm going to put the extensions on the tack switches. You can do this before you put the panel on too. I just prefer to do it this way because I get a better sense of the final depth. Before I tighten everything up for good, I check all the switches to make sure they're not rubbing against the side of the panel or anything like that. But now it's time to put all the panel nuts on, and I will be speeding up playback on this and probably cutting some of it out because it's not the most exciting thing in the world. Now we'll pop on the knobs, and again they've got flat sides to them. There's a flat side on the shaft that corresponds to the flat side inside the knob, so you don't have to worry about getting the index marks lined up. They should naturally fall in. One thing you'll notice I'm doing here, I am not pushing on the circuit board when I'm pushing these knobs on. Put my fingers on the metal front panel because I don't want to put force on the circuit board because you never know what will happen if you do that. Okay, and we've got all that, and now we've got our power connector. And again, negative 12 volt is there. So we'll put the connector on like so. And I'm going to do one more pass with my index card to make sure I got everything soldered. I missed that one leg on that one jack. I mean one pot. I'll get that in a second. Not that that's critical for electrical conductivity, but it does give it additional mechanical support. So now let's put it in the rack and LFOize it, and also we'll find out what this jumper is for. Alright, we're in the rack and haven't turned it on yet. Let me bring the scope up. And again, this is a Euclidian LFO, and don't let the name put you off. It simply means they're using math to split a number of beats inside a cycle. So you can look up Euclidian LFO or whatever on Wikipedia or elsewhere and find real good descriptions of the actual math involved. So let's power it up, and I've got the scope up just so we can see what it's going to initially come up with. And it's not coming up with anything because this scope is dumb. Why is this not doing anything? It's just so you can see we've got some stuff going here. Let me tap for a tap. I'm not seeing anything on there's the scope. But I'm not actually seeing anything. I think we got everything figured out now. So let's see, let's start out. I'm going to do a tap tempo. And now you can see on the scope, you've got the number 1, the master, which is the yellow line at the top, then number 2, number 3, and number 4, all putting out slightly different waveforms. Now if I change, let's do some simple stuff. We'll change the shape. Now you can see the shape of the wave you're getting. Now we'll take it to almost a plain sine wave. That's nice. Go back to triangle. I'm going to take length down a little bit. Which acts differently than I would have thought, but that's okay. So if you'll notice, as I go all the way down, LFO3 just flattens out. If I go all the way down, now I can bring it back up, and LFO3 comes back up. Let me go all the way high on length. And now you can see LFO4 is really slow. Go back to the middle. Now we'll go to density. Take density all the way down, and with density all the way down, it basically turns everything off. And I bring it up a little bit, and you can see the different interactions on the different waves. Some are not quite in sync. The 4 and 1 seem to be in sync. 2 is a little trailing. 3 has got a bunch of stuff inside it. Let's go density halfway up. Now you can see that. Take density all the way up, and again that's where the LFO3 flatlines out. Back it off. And I've got my sequencer running based on this. So what I'm going to do is I'm going to change the sequencer, which is coming off 2 right now. I'm going to change the sequencer to 4. So much slower, as you can expect. Now I'm going to tweak the we'll go to 3 right now and give that a listen. I think I changed the wrong thing right there. Did I? What am I doing? I did change the wrong thing. I don't know what I actually did. Change the density again. You can see it's a different rhythmic pattern. Now I'm going to change some other things. I'm going to go to a different table. Go to the next table. Go to the next table. Back to the original 1 and 5. I'm going to change mode to random. As you can see, there are different random peaks that are coming out of here. I'm going to set the density higher. I'm changing the length a little bit. Now I'm going to use a different LFO to come in on clock so I can speed this up a little bit, just for fun. That's with an external LFO driving everything. Take length all the way up. Take density all the way up. Take density all the way down. I'm going to go over here to phase shifted. That doesn't, you're not going to see a noticeable, you see that the top yellow is up when the other two are down. Actually, I can't really tell. While 2 is down and 3 and 4 are up. Go back to that. I'm going to slow this down again. We'll go unipolar to take everything just above 5 volts. We're not getting any negative on that, which is good. We're doing a P-sync here. I forget what that actually does. So we'll take that back off. I'm going to take the LFO out of there and do another tap tempo. And I'm going to use the LFO to vary length. Now you can see what it's doing there. It's changing the length semi-at-random across all the outputs, which is interesting. Let's put it into DNST, which I forget what the heck that is. Let me see what DNST stands for. Density. Okay, so that's the density input. And it's varying that according to the LFO. Let me speed that up. If I take that down, you'll see it's reducing on the downslope of the external LFO. It's reducing the density to 0. Then we've got the shape, and that's kind of neat, isn't it? So we've got the shape being modified constantly by the external LFO. And now we'll do symmetry, because I didn't actually show that yet. But let me go ahead and do that, because symmetry again will go this way and it's a full strong attack, and we'll go full the other way and it's a ramp up and a descent, relatively straight descent down. So that's all we're basically doing. We've got a whole bunch of stuff that I'm not going to get into. So if I change, I'm looking for the buttons he's saying. Use the button in the LEDs menu. We can get a variety of interesting things happening there. I'm going to move this back to the center. So I'm also I wanted to do something else here. I'm going to take the even VCO out for a moment, grab another cable, take the even VCO output, put it in to my is this even plugged in? Hold on a second, I gotta check to make sure I got this plugged in right. Oh, forget that. Never mind. I'm not gonna mess around with all that. So that's what we got. And again, there's lots of things you can do to control this, to store and recover things, to do all kinds of stuff. It's an interesting unit, and I think you'll probably find a very good use for it, to have a good LFO with different interesting things happening alongside it. So again, it's got a great deal of depth in the wave tables you can go with on syncing. correlating outputs and other things, I would recommend you go to their website and look at all the demo videos they have. So pretty quick build because, again, mostly surface mount pre-installed. And a good unit if you want a more interesting multi-LFO, and they can always be handy. And I hope you enjoyed the video.